NASA astronaut Bob Hines is training right now to walk on the moon, but when he finally gets there, the AI-driven machines will have arrived years before him, not to greet him, to build his home. Here's what almost everyone has wrong about the moon base story. We picture astronauts stepping off a lander, planting a flag, and starting construction. That is not what NASA's actual plan says. The real building begins on a timeline most of the public has never seen, and it starts without a single human being on the lunar surface. In the next 12 minutes, you will find out exactly how NASA plans to use autonomous robots to construct humanity's first off-world base before any crew ever arrives, what NASA's own technical papers say about why the robots go first, and the one detail buried in those documents that changes how you understand what the moon base actually is. The program costs $20 billion, and the machines don't wait for permission. NASA has published the technical architecture for this robot-first construction approach. It is called the Lunar Innovation Park, and the language inside those documents is not the language of exploration. It is the language of something else entirely. That is what this video is about. And there's one question those papers raise that nobody is asking, yet a question we will get to by the end. Let's go back to March 2026. NASA makes a decision that surprises almost everyone in the space community. They cancel the Lunar Gateway, the orbital space station that was supposed to serve as a staging platform for moon missions. The Gateway was a multi-billion-dollar international project with partner agencies from Europe, Canada, and Japan. Years in the making. Gone. Instead, NASA announces something more direct, a $20 billion program to build a permanent base on the lunar surface itself, near the South Pole. Bob Hines, the NASA astronaut assigned to Artemis, the first crewed lunar landing since Apollo 17 in 1972, describes the base as the destination his entire mission is building toward. He talks about it in terms of permanence, not a camp, not a waypoint, a base, something you live in. And when NASA releases its planning documents for that base, the first detail that jumps out is the timeline. Artemis 3, the first crewed landing, is targeting mid-2027. The moon base itself, with habitats, power systems, rovers, and construction equipment in place, is not expected to reach full operational status until 2032. That is 5 years. 5 years during which humans will make brief visits to the moon, while the base is built and operated almost entirely by machines. Here's the thing, common sense says you build the base and then move in. That is how every construction project in human history has worked. Humans arrive, humans build, humans inhabit. Yet NASA's plan runs the opposite sequence. The robots go first, the humans follow. Why? And this is the part almost nobody has reported on. The answer lives in two technical papers published in 2026 through NASA's technical report server NTRS. The documents are titled Lunar Innovation Park, and they describe something that sounds less like a science mission and more like a startup pitch. The Lunar Innovation Park, the LIP, is described in NASA's exact words as an infrastructure hub of co-located landers designed to stimulate space resource-based economic activity through sustained robotic surface operations that enable the exchange of goods and services. Read that again slowly. Goods and services, exchange, economy. The robots aren't just building a shelter, they're building a market. The reason the robots go first becomes obvious once you see the economics. Sending a human to the moon costs roughly $1 billion per astronaut per mission under current estimates. Keeping humans alive on the lunar surface requires life support, radiation shielding, pressurized habitats, food, water recycling systems that each take years to certify and deploy. Robots don't need any of that. A robot doesn't breathe. It doesn't eat. It can work through a 354-hour lunar night a night 2 weeks long without stopping for a single second. So NASA's plan is to send machines in first, build as much infrastructure as possible while costs stay low, and only bring in humans when there is already a functioning base to receive them. It is less like colonizing the frontier and more like building the hotel before you open for tourism. Can't sell the rooms if there's nowhere to stay. Here's what the machines actually looks like on a manifest. Blue Origin, Jeff Bezos' space company, was selected over SpaceX for the first moon-based delivery contract. That surprised a lot of people. Blue Origin's Blue Moon Mark 1 endurance lander will carry the first payload wave to the South Pole. That payload includes Astrolab and Lunar Outpost moon buggies autonomous rovers that can navigate the lunar surface without a human driver at the controls. Firefly Aerospace will deliver rocket-powered hopper drones that can jump between locations, scout terrain, and move small payloads. Astrobotic's Griffin 1 lander, built in Pittsburgh, is being prepped for Moonbase 2, the second supply wave. This isn't a single historic rocket launch. It is a supply chain, the same kind of phased logistics operation a construction company runs when it builds a skyscraper, except the job site is 384,000 kilometers away, and communications run on a 3-second delay. Now here's the problem those machines are going to face that barely anyone is talking about. Power. You might expect a machine running on solar panels on the moon to be fine most of the time. After all, the moon has no clouds, no atmosphere to block sunlight, and yet the moon's south pole has a 354-hour lunar night. 2 weeks of total darkness. Here on Earth, losing power for a day is an inconvenience. On the moon, losing power for 2 weeks means your construction robots stop. Your heating systems fail, and any partially assembled structure could crack under temperature swings of nearly 300 degrees Celsius, going from the temperature of boiling water to colder than dry ice, twice a month, every month, forever. NASA's solution is nuclear. Rolls-Royce, the British engineering company better known for jet engines and luxury cars, has been funded to develop a miniaturized fission reactor specifically for the moon, not a solar array backup. An actual nuclear power plant designed to fit on a lander and run continuously for years without human maintenance. The same company that makes the Phantom and the Ghost and the Wraith is building a nuclear reactor for the moon, and the plan is for it to be running autonomously before Bob Hines and his crew ever land. Most people use Moonbase and Outpost as if they mean the same thing. They don't. An outpost is something you build to visit. A base is something you build to stay. The difference isn't poetic, it's operational. An outpost survives on batteries. A base needs a power grid. And a power grid on the moon means nuclear energy running autonomously around the clock. That is the line NASA just crossed, not in a science fiction film, but in funded engineering contracts signed this year. Meanwhile, a stranger story is emerging alongside the construction plan. Companies, SpaceX included, have been proposing electromagnetic catapults on the lunar surface, mass drivers, devices that accelerate cargo containers to lunar escape velocity and launch them off the moon without a rocket. Think of it like an electric railgun, the length of a football stadium, except instead of a projectile, it's launching cargo. The economics are compelling. Launching from the moon is far cheaper than launching from Earth because lunar gravity is only 1/6 of ours. You need far less energy to escape it. But a report published in June 2026 raised a flag that nobody initially expected. A mass driver powerful enough to launch cargo toward Earth is powerful enough to launch kinetic impactors toward Earth. The same device that ships lunar helium-3 to power plants on Earth could, in theory, be pointed at a target. The moon, in that scenario, stops being a science base. It becomes the highest ground humanity has ever occupied. And that is exactly why the China angle matters. China's International Lunar Research Station, the ILRS, is being developed in parallel, with Russia, the UAE, and several other nations signed on. China has announced plans for a robotic lunar base by 2035 and crewed missions to follow. Executive Order 14,369, signed by the White House in December 2025, entitled Ensuring American Space Superiority, provides the explicit policy backing for the Lunar Innovation Park, and buried inside those NTRS papers is a word that doesn't appear in most moon-based coverage: perimeter. NASA is already planning a security perimeter around its lunar assets. 54 years after the last human left the moon, the race back has started, and the first wave isn't astronauts, it's robots. The second wave, the wave right behind them, is nations. Here is what the full timeline looks like when you put it together. 2026, uncrewed landers begin delivering the first equipment to the South Pole. Blue Origin's first payload, Astrobotic's Griffin 1. The initial robotic survey and construction phase begins. Humans, 0. 2027, Artemis 3 lands. Bob Hines and his crew spend approximately 2 weeks on the lunar surface. They are not building the base, they are visiting the construction site. Think of it as a site inspection. 2028 and beyond, follow-on missions deliver habitat modules, power infrastructure, and more advanced robotic equipment. The Rolls-Royce nuclear reactor goes online autonomously. The Lunar Innovation Park begins what its papers call sustained robotic surface operations. 2032. NASA's target for the first permanent human habitation, rotating crews living at the base for extended stays, the beginning of what those documents describe as a space resource-based economy. That's 10 years, a decade of mostly robotic construction before humans move in. Now here's the question we raised at the start. The robot's first approach, will it actually work? The technical challenges are enormous. Lunar dust regolith is electrostatically charged and razor-edged at the microscopic level. It destroys moving parts, clogs seals, and degrades solar panels faster than almost anything in the natural world. Radiation on the lunar surface, without an atmosphere or magnetic field to filter it, will slowly corrupt the electronics in every machine NASA sends. And the 3-second communication delay from Earth means the robots cannot be remotely controlled in real time. They must operate with genuine autonomy, making decisions independently when their instructions don't cover what's in front of them. These are not solved problems. But the Lunar Innovation Park papers describe a phased approach that accounts for this. Start with simple, robust hardware. Prove the supply chain, validate the power systems, build complexity slowly. It is less like constructing a city and more like establishing a port, infrastructure first, civilization second. And Bob Hines, when he steps off his lander in 2027, will not walk into a finished base. He will land near a construction site run by machines. He will walk through hardware that has been tested, relocated, and operated for months by autonomous systems that have never met a human being. And when at some point during that mission, a human hand first opens a door that a robot built on another world, something genuinely unprecedented will have happened. For all of human history, every building ever raised began with a human hand picking up the first stone. Every city, every shelter, every bridge, human labor, human decision. NASA is designing the first civilization in history where that will not be true. The moon base will exist before any human lives in it. The power grid will be running, the roads will be graded, and when the first permanent residents finally arrive, they will be moving into a home built for them by machines that had never seen another living thing. Whether that is the most extraordinary thing our species has ever accomplished or the strangest might depend on how you feel about who we're becoming. Subscribe if you want to be here when we cover what's waiting beyond the moon, something the next wave of missions has already found that no model predicted.